So variation of atomic radius in 3D series elements. So scandium to zinc. So actually scandium atomic number 21, its electronic configuration based on nearest noble gas argon 18 and 4s2 it is 3d1. So titanium is one unit of atomic number increases from left to right. So then it is 3d2. So then it is the 3d3. So then it is a 3d5. What is a 3d5? Exceptional electronic configuration. It is also 3d5. It is the 3d6. It is 3d7. It is 3d8. So it is 3d10 and it is 3d10. What is a 3d10? So from left to right, atomic number increases, number of electrons increases, but the differentiating electron enters into the same energy level, that is 3d. So due to number of electrons increases in a particular shell, nuclear charge increases, size what happens to decreases. Size what happens to decreases. So the order is scandium greater than titanium, greater than vanadium, greater than chromium, is greater than manganese, is greater than cobalt. So then cobalt equal to nickel. Nickel is less than copper. Copper is less than zinc. Copper is less than zinc. So now two exceptions are present in this order. Okay, two exceptions are present. Actually from scandium to cobalt, atomic radius is decreases. Then nickel to copper increases because it is copper is the stable electronic configuration. But it is a stable electronic configuration, and copper to zinc also increases because it is the phenomenon of shielding effect. It is a phenomenon of shielding effect. What is it? It is the phenomenon of shielding effect. Okay, due to the shielding effect, the atomic size of zinc is greater than copper. Copper is greater than what is a nickel. What is a nickel? So now what is shielding effect? So now shielding effect. Shielding effect. What is shielding effect? Or screening effect. Shielding effect and screening effect. Shielding effect or screening effect. What is the shielding effect and screening effect? It means simply it is the nucleus. It is first orbit, second orbit, third orbit, fourth orbit, like that. So now it is the valence electron. What is a valence electron? Some electrons are present in inner shells. What is some electrons are present in inner shells? So now valence electrons, except valence electrons, remaining electrons is known as core electrons. What are these? Are the core electrons. So now core electrons protect the valence electrons from nuclear charge. What is a nuclear charge? So due to this phenomenon, reduction of nuclear charge on valence electrons by inner electrons is called screening effect or shielding effect. It means core electrons are inner electrons. Core electrons are, these are the inner electrons, act as screens. What is it? Act as a screen. Act as screen. So due to screening effect, so nuclear charge is less on what is valence electrons. Nuclear charge is less, size what happens to increases. So it is the shielding effect or screening effect. So now the order of the D block elements, that is 3D series elements, from scandium to cobalt decreases. So then cobalt equal to nickel. Nickel is less than copper. Copper is less than zinc. So zinc with a large atomic radius in 3D series. So it is the screening effect and shielding effect. So now next, atomic radius in 3D lanthanides. What are variation in F block elements? Radiation of atomic size or radius in F block elements. What are in F block. What is in F block elements? F block elements. Okay. So generally F block elements are classified into two series. One is lanthanides, second one is actinides. What is actinides? So now, for example, let us consider lanthanides. What is lanthanides? So lanthanides are belong to 4F series. What are 4F series? So then what are the 4F series elements? From atomic number 58 cerium to atomic number 71, that is lutetium. What is 71? Lutetium. It consists of 14 elements. 14 elements. So now cerium to lutetium atomic size. What is atomic size is decreases, but this decreasing atomic size is gradually decreases or steadily decreases, because in this lanthanides, lanthanide contraction is present. What is a lanthanide contraction? What is a lanthanide contraction is present. So what is lanthanide contraction? Lanthanide contraction means the steadily decreases, the gradual decreases of atomic radius in lanthanides from left to right is called lanthanide contraction. What is a lanthanide contraction? So then, lanthanide, due to the lanthanide contraction, it is a poor screening effect, or what is a poor shielding effect is present. What is a poor shielding? What is a poor shielding effect is present in lanthanides. What is a lanthanides? So now actually it is represented with graphical. So then atomic number is taken on x-axis. So then atomic size is taken on y-axis. So from cerium to lutetium, what happens? Size is decreases. Cerium to what is cerium to lutetium size? What happens? Decreases. It is a decreases. It gives the negative slope. It is cerium to what it is the lutetium. That is a lutetium. So now consequences of lanthanides, or consequences of lanthanide contraction. Lanthanide contraction. So what are the consequences of lanthanide contraction? Number one is due to similar structure. What is a similar structure? So similar structure and other properties of lanthanides. So and other properties. What are other properties of lanthanides? Then separation of lanthanides from mixture is difficult. So due to similar structures and other properties of lanthanide mixtures, lanthanide elements, separation is difficult. What is a separation is difficult. Separation is difficult. What is difficult? So separation of lanthanide elements from their mixtures is difficult due to similar structure and other properties. Similar other properties. So now actually this lanthanide contraction is present in transition elements also. Actually transition elements are classified into 4 series. What are 3D series, 4D series, 5D series and 6D series incomplete series. So from top to bottom 3D to 4D, 4D to 5D, size what happens? So increases. So 3D is greater than what is 4D. Okay. So then 4D is less than 5D, or 4D is equal to 5D. Why 4D series radius is equal to 5D? Due to the lanthanide contraction. What is due to lanthanide contraction? So next third one is due to lanthanide contraction, the basic strength of lanthanides decreases from left to right. Basic strength. What is basic strength? Basic strength of lanthanides what happens? Decreases. Basic strength decreases. So then it is the cerium. What is cerium hydroxide? CeOH taken thrice. It is decreases. to decreases what is lutetium hydroxide. What is lutetium hydroxide? So cerium hydroxide with less covalent nature, it is the more covalent nature. So covalent nature increases from left to right, and basic strength what is decreases due to the lanthanide contraction. What is lanthanide contraction? So the next one is generally in heavy metals. Okay, what are heavy metals? Inert pair effect is present in heavy metals. What are in heavy metals? Inert pair effect is present. So then, what is inert pair effect? What is inert pair effect? So inert pair effect means non-participation of ns electrons in bonding is called inert pair effect. So then non-participation 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 of ns, what is a ns electrons, ns electrons in bonding, what is a ns electrons in bonding is called inert pair effect. Actually it is present in third group, fourth group and fifth group elements. So now what are the third A group elements? It is the boron, aluminium, gallium, indium and what is a thallium. So thallium show the inert pair effect. Same as fourth A group elements. What are fourth A group elements? Carbon, silicon, germanium, tin and what is a lead. Lead also show the inert pair effect. So then fifth A group elements. What are nitrogen, phosphorus, arsenic, antimony and bismuth. So bismuth also show the inert pair effect. So generally third group elements general electronic configuration is NH2, it is NP1. So it is NH2, it is NP2. So it is NH2, it is NP3. So in NH2, NP1 only it thallium loses p electrons. But